Go through LeetCode 973 K closest points to origin. The question gives us a lot of points. I said the size is greater than K. Let us to greater equal to K. Let us to find the K closest points and return those kind of point array. So for this kind of for every point, we know, for example, we know for each first index, right, the index 0 get a point, it will be an array with 2 elements. So we want to for this kind of points, for example, we have n points get the top K. So for top K, one of the we always use something like a quick select to do that because it will be ON time complexity to separate those kind of endpoints to get the top K. So the same thing like we write for top K question. Let's write code for this. Let's say int a equals point x, and our result will be new int. So we'll find the K, and also the point to return result. We'll do quick select int point. Let's say that is points, and our start index is 0, and the index is n minus 1, and also it will be K minus 1 as we pass the index into it. I equals 0 minus n K I plus the result I equals 1. So we'll use a quick select to get a partition the points array into 2 parts, and the first part have K element, and we'll have the shortest smallest K points and distance points to the first partition. And let's write a help function that int get this for a point that will be 2 x and y point. Actually, we don't need to have the square root for the result, because x or y, they in this kind of range, minus the 10 power 4 to 10 power 4. And if we add it, we can return, it will not exceed the integer maximum. So we just return point 0 multiplied by point 0 plus point 1 divided by point 1. So we get the top k smallest distance to origin is that the same as we get a top k for this kind of value. So we are ready to pick select. I will this will return the index. Pick select int point points and the int start int and int index. Let's say if start greater equal to n, means we finish the partition. We just return index. So we write partition left equals start, right equals end. So let's say pivot equals points start plus end divided by 2. So we'll say while left smaller equal to right, while left smaller equal to right, and it dist point left smaller than get the dist pivot. That means we are putting the smaller distance on the left, and then we can move the left pointer. While left smaller than right, and with this pointer right, if it is greater than it is pivot. That means on the right it is a larger distance. It have a right minus minus. And if we jump out these two while loop, that means now the left we have a distance for this kind of left index. The point distance is greater than the pivot one, and greater equal to the pivot one. And the right one is smaller equal to the pivot one. So let's say if scale left smaller than right, we need to swap. Let's say int 10 equals points. This should be points, not points. Points left. And the points left equals points right. And the points right equals 10. And the left move on one step right on one step. So after a while loop, let's say the left will be on the right of the right index. So left will be here, and the right will be here, and this is the start. This is the end. So we want to see if the index is falling in this range or this range. So let's say if index greater equal to start and index smaller or equal to right, will return pick select points. It is start. Now it's the right index. Same thing is if we index greater or equal to left, because left is on the right part. The start the lower bound is left now, and index smaller or equal to n. We have to return pick the left once. Once now should be left and index, and that and return index. Quick select 34. Not quick select. So what's a time complexity is O n. Assume there are n points. The space complexity would create n k multiplied by 2 array. So space let's say it's OK.